Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio.
Triangles.
In the last video, we have discussed the definition of similar triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. In this video, we will discuss one of the important theorem in this chapter called basic proportionality theorem. The theorem states like this.
If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. This is the theorem. We want to study the proof also for this theorem. This is called basic proportionality theorem. Basic proportionality theorem. Okay, so we have applied this theorem when we divided a line in the given ratio in the chapter constructions. Okay, so theorem says that if a line drawn parallel to one side of a triangle, so we have a triangle here. Suppose this is a triangle, we can give some name PQR. The theorem says that if a line is drawn to parallel to one side of a triangle. So suppose I draw a line here, I give name MN. Suppose this line is drawn parallel to one side of a triangle, that is PQ. Intersect the sides in the distinct point, that is M and N, two distinct points M and N. The other two sides are divided in the same ratio. This M and N will divide the other two sides in the same ratio, that is RM is to MP. RM is to MP is equal to RN is to NQ. This is what the theorem says. I shall explain again. We have a triangle PQR, and we draw a line MN parallel to one side of the triangle, that is PQ. The theorem says that this M and N will divide the other two sides in the same ratio. That is RM is to MP will be equal to RN is to NQ. Okay, I think you remember this theorem we have applied when we divided some line in given ratio and consistent, right? We have applied the same theorem. So we want to discuss the proof of this theorem. Then we will do the reverse of this theorem. Okay, here if the line is parallel, then this condition is true. The second theorem is just a reverse. If this ratios are same, then the MN is parallel to PQ. And we'll discuss after this. Yeah, so let's prove this theorem. If a line is drawn parallel to one side of a triangle, that line divides the other two sides in the same ratio. Okay? So I shall draw a triangle here. So I draw a line parallel to PQ. Suppose the name is PQR, and I draw a line like this. Okay, the name is PQ is already there. Suppose MN. Okay, MN is drawn parallel to PQ. We want to prove this theorem. So first we considered a triangle named PQR. Then we drew a line parallel to one of the side of triangle PQR, that is MN parallel to PQ. We drew one line segment. Okay, we want to prove that. What we want to prove? This M and N, the points M and N divides the other two sides in the same ratio. That's what RM by MP is equal to RN by NQ. This is what we want to prove. So what do you want to prove? Okay, we want to prove that RM is to MP, that is RM by MP, is same as RN is to NQ. So for that, we have to draw some more lines in this picture. I join M and Q. I join M and Q. And also I join P and N. And I mark the height of triangle triangle MRN, height of triangle MRN. Suppose it comes here. This is height of triangle MNR. Suppose MR is taken as the base. The distance, the perpendicular distance from MR to N. So we can give some name here. Suppose some other letter. We use, suppose A. Okay. Suppose AN is perpendicular to MR. AN is perpendicular to MR, and also we'll draw one line perpendicular to RN. Okay, this line we can give some name MB. From M to B, we have drawn such that this angle is 90 degree. That is MB is perpendicular to RN. MB is perpendicular to RN. So we do 4 lines. One, we just joined P and N. We joined M and Q. Okay, and we have drawn perpendicular from N to RM, and also perpendicular from M to RN. These are the lines we have constructed. Okay. Now, using the area of a triangle, we want to write some of the areas. Okay. My first question: what is the area? Area of triangle MNR. Okay. In short, we can write area of triangle MNR like this. Area of triangle MNR. What will come? Area of triangle MNR.
Area of triangle AMN plus.
Okay. And no need like so. You use the formula of BH. If you know one side and the height from that side to opposite corner, opposite vertex, you can calculate the area, right? So you know any side of this triangle and the distance, the height from that side to opposite corner.
Into MR.
Suppose I choose base as MR. Base as MR. What will be the area?
MR into AN.
MR into A, half into MR into AN will come, right? Half BH, right? Half BH. So here base, if we choose RM, so here MR and RM are same, okay? MR into, then the height from MR, the side MR to the opposite vertex is AN, right? We have marked here 90 degree. Okay. So AN will be the height of the triangle if MR is chosen as the base. So half into MR into AN will come. Okay. Now what is the area of triangle PNM? Triangle PNM. What is the area of triangle PNM? The heights need not be always inside the triangle. So look here, one triangle here. Where will the height of this triangle come? Suppose AB is chosen as the base. So will now come outside the triangle, right? Like this. The height will be marked outside, right? Suppose AB is chosen as the base. Then the height from AB to the third vertex.
Sir, AN.
AN, yes, right. AN will be the height if MP is chosen as the base, right? It's compare with this picture. For this triangle ABC, if AB is chosen as base, then the height will be outside this triangle. Here similarly for this triangle PNM, if PM is taken as the base, then the height of the triangle will be AN, right? Because that there you can see 90 degree. PR, the line PR, the line segment PR is the extended line of line segment PM. So the height of the triangle, if PM is taken as base, will be AN, line segment AN. So the area of PNM, how will come?
Half into PM into AN.
PM into
AN. PM into AN will come. Okay. So I keep it like this. Now area of MNR again. Area of triangle MNR again. We already discussed MNR here. Area of MNR again. If NR is taken as base. If NR is taken as base, how will come the area of triangle MNR?
Half into BM into NR.
It's half into NR into BM will come. BM, right? Because The BM is the perpendicular distance or the height of the triangle from the side NR to the vertex M. Okay, so if NR is taken as the base, then the height of the triangle will be BM. Then we can find the area of triangle QNM. What will be the area of triangle QNM? Area of triangle QNM. I have marked the height, one height of this triangle.
Half into Q1 into BM.
BM into
Yes,
B2.
Q1 into
BM.
BM, very good. Okay, BM. Okay, if QN is taken, the triangle name is QNM. Okay, triangle name is QNM. In this triangle QNM, if QN is taken as base, then the height will be here outside the triangle MB or BM. Okay, so we can mark here. So the area of the triangle QNM will be half into Q1 into BM. Now we can divide this these two. Like here we divide this by this and this by this also. Okay, so here I shall write area of triangle MNR divided by area of triangle PNM. Area of triangle PNM. Okay, so what will we get? What will we get? In the top you can write this half into MR into AN. Okay, in the bottom, in the denominator we can write half into PM into AN. Okay, some terms will be cancelled, right? Which all?
AN.
AN will be cancelled and half will be cancelled, right? Half will be cancelled. What's the balance? Area of triangle MNR divided by area of triangle PNR. What is balance?
MR divided by PM.
Yes, PNB is equal to MR divided by PM. MR divided by PM. In the right side also we can divide like this. Area of triangle MNR, area of triangle MNR divided by area of triangle QNM. What will come? We can
NR
cancel
by
some of the
QN.
terms, right? Half into, yes, NR. I think no need to write complete because we know some half will be cancelled and BM will be cancelled, right?
Yeah, NR by QN.
NR by QN. NR by QN will come. NR by QN will come. Okay. Now you look here. Here area of PNB. Okay, I made small error. PNM. Okay, not PNB here. PNM. Sorry. PNM. Sorry, a triangle PNM, right? PNM. Okay. Look here, a PNM, triangle PNM, and a triangle QNM. Any relation between their areas? These two triangles.
They are equal.
They are equal, right? Triangle PNM and triangle QNM. They are equal. Why they are equal? Why they are
Base
equal?
same.
Base is same and they lie between parallel lines, right? They lie between parallel lines. In 9th standard, you have studied a theorem. If base of two triangles are equal and they lie between two parallel lines, so their areas will be equal, right? So I shall draw a picture here. Suppose AB is parallel to some line. Okay, so suppose this PQ or some other name. Okay, suppose the two triangles like this. One is like this, and some other one like this. Okay, ABC and ABD. Are the areas of triangle ABC and ABD equal? ABC and ABD equal? Yes, right? Because their bases are equal and the third vertices are on a line parallel to base. Okay, same condition we can apply here. MN are base of these two triangles. They are equal. And the third vertices P and Q are on a line parallel to MN. Okay, so these two triangles lies between two parallel lines with the same base. Okay, so their areas will be equal. Their areas will be equal. So area of triangle MNR divided by area of triangle PNM will be equal to area of triangle MNR divided by area of triangle QNM. Okay, So if this is equal to this, then the RHS will be also same. Okay, what is RHS? RHS MR by PM is equal to NR by QN. Okay, that's what we want to prove. That's what we want to prove. Here you look, RM means MR. RM and MR are same. RM by MP is same as PM. Is equal to RN by NQ. RN is NQ, NR, right? RN by NQ. So the theorem is proved. Okay, so I shall repeat this. Okay, so our theorem says that in a triangle, if one line is drawn parallel to one side of a triangle, then that line means the endpoints of that line segment will divide the other two sides of the triangle in the same ratio. Yeah, so here MN is drawn. In this picture, to prove this theorem, we have drawn one triangle PQR and one line segment MN is drawn intersecting the other two sides at M and N. Then we want to prove that the ratio of RM and MP is same as ratio of RN and NQ. That is, RM by MP is same as RN by NQ. So for what we have done here, first we joined MQ and PN. We joined MQ and PN, and also we have drawn two perpendiculars from this point N to MR. We have drawn one perpendicular, and point M to this NR we have drawn one perpendicular. Then we gave name A and B. Okay, and first we wrote the area of triangle MNR. So area of MNR, if MR is taken as base, will be half into MR into AN, because AN is the perpendicular from MR to N. Okay, and area of PNM is half into PM into same height AN. Okay, and if you divide these two, you will get MR by PM, equation number 1. Okay, and right side, area of MRN is taken in different way by taking RN as the base. Then the area will be half into RN or NR into BM. BM is the height from this base RN to the third vertex. Okay, then area of QNM. Area of the QNM will be half into QN into same height BM will come. Okay, if you divide these two, you will get area of MNR by area of QNM is equal to NR by QN. Question number 2. Okay, combining question number 1 and 2, here since the area of triangle PNM is equal to area of triangle QNM, we can write that, and the numerators are same, right? MNR triangle names. Okay, so since these LHS of this question number 1 and question number 2 are same, the right side RHS will be also same. So we get MR by PM is equal to NR by QN. That's what our target. In construction, we have applied this theorem. We didn't give any proof, but we simply applied this.